Hello everyone! In today's topic, we are going to discuss about sets. Sorting given objects into groups. So if we have these plants and animals, we are going to group it. So objects can be arranged into groups according to their common characteristics. The first group are the plants and the second one are the animals. So obviously the cat will fall under the animals, the coconut tree will fall under plants, and the rat under animals, the hibiscus under plants, and another type of tree under plants, and the duck under animals. So that is how we sort things and how we group things. It must be defined. Defining a set. A set is a collection of objects which have a common property. The objects in a set are called the members or elements of the set. A set must be clearly defined. It can be defined by using A. Description, B. Set notation. So using the set notation, we have the curly braces. So example for this one, under description, the set of the first 5 numbers. If we are going to use the set notation, it looks like this: 2, 4, 6, 8, 10. A set is usually denoted by a capital letter. For example, A is equal to 2, 4, 6, 8, 10. It is read as A is the set of the first 5 even numbers. There are 3 ways to define a set using a set notation. For example, set A is equal to the first 5 even numbers, or A is the set of the first 5 even numbers, or A is the set of 2, 4, 6, 8, 10, or A is the set of all 2x such that x is an element of n and x is greater than equal to 1 but less than equal to 5, which is we will be discussing it later on, the set builder notation. So there are important symbols to be remembered when studying sets. So we have, it is an element of, it is not an element of, union of sets, intersection of sets, empty sets. And I included 2 important sets of numbers. The capital N, it is the set of natural numbers, or it is the set of counting numbers. So if we are going to write the set of N, it is equal to 1, 2, 3, 4, 5, and so on and so forth. So it is continuous. And I included set, which is equal to the set of integers. So set is equal to ... -2, -1, 0, 1, 2, ... Meaning this ellipsis means that it is infinity. So it goes on and on without any ending. It does not end at all. Now let us have identifying elements of a set. So remember that A is the name of the set and these are the elements. So we are going to identify whether a number is an element or not an element of a set. So if A is equal to the odd numbers less than 12 and B is equal to the factors of 18, fill in each of the boxes with a symbol. So remember, odd numbers start with 1, 3, 5, 7, 9, 11, and so on and so forth. And let us determine if 7 is an element of set A, is 5 an element of set B, is 13 an element of set A, and 18, is it an element of set B? So what do you think? So is 7 an element of set A? Definitely yes. Is 5 an element of set B? No, it's not. It's not an element of set B. How about 13? Is it an element of set A? No, it is not an element of set A. How about 18? Yes, it is an element of set B. What is set builder notation? So if we have A is equal to 1, 2, 3, 4, and so on and so forth, this is the set notation. Now we are going to have the set builder notation. So to rewrite this one in set builder notation, we have it is the set of all x such that x is an element of n. So we all know that the capital letter N stands for the set of natural numbers or set of counting numbers. So we can read this one as A equals the set of all x such that x is an element of n, which is the natural numbers. Remember that this bar is read as such that. Now let us have another one. B is equal to 1, 2, 3, 4, and so on and so forth, 57. So in here, we have limited to 57. So how do we write the set builder notation? So first, we are going to have, it is a set of all x such that x is an element of n. But because we have 57 here, we are going to limit our x. So and x is greater than equal to 1, but less than equal to 57. So we can read this one as B equals the set of all x such that x is an element of n and x is greater than equal to 1 but less than equal to 57. So we can read this one as x is greater than equal to 1 and this one but less than equal to 57. It is really very important that students can read the symbols. Now let us have another one. Set C is equal to 2, 4, 6, 8. Remember that 2, 4, 6, 8 are even numbers and are divisible by 2. So our clue here, we are going to multiply the natural numbers by 2. So if we are going to have the set builder notation for this set C is equal to the set of all 2x such that x is an element of n. So we can read this one as C equals the set of all 2x such that x is an element of n. Now let us have another one. If we have set D is equal to 2, 4, 6, 8 and so on and so forth, or until 200. So remember that 2, 4, 6, 8 up to 200 are even numbers and are divisible by 2. So in writing this one, we have the set of all 2x such that x is an element of n, and we are going to limit it. So x is greater than equal to 1, but less than equal to 100. Why 1? Because 1 times 2 is 2. And why 100? 100 times 2 is 200. So we can read this one as D equals the set of all 2x such that x is an element of n and x is greater than equal to 1 but less than equal to 100. Now let us have another one. So E is equal to 1, 4, 9, 16. In here, before we are going to make or to convert it into a set builder notation, let's take a look at the pattern. So 1, 4, 9, 16. So what do you observe with this one? So 1, 4, 9, 16 are square numbers. They are perfect squares. So meaning, if we have 1 squared, it is equal to 1. 2 squared, it is equal to 4. 3 squared is equal to 9. 4 squared is equal to 16. So we are going to base our answer with that. So we have E is equal to the set of all x squared such that x is an element of n. So we are going to square the counting numbers. So it is read as E equals the set of all x squared such that x is an element of n. Now, how about if there is a limit on that? So if we have e is equal to 14916 dot 100, or 14916 and so on and so forth up to 100. So 14916 up to 100 are square numbers or perfect squares. So we are going to have E is the set of all x squared such that x is an element of n. Since we have 100 over there, we are going to have x is greater than equal to 1, but less than equal to 10. So if we have 10 squared, it is equal to 100. Okay? So you can read that one as E equals the set of all x squared such that x is an element of n and x is greater than equal to 1 but less than equal to 10. Now let us have a short quiz. Write in set builder notation the following in 5 seconds. That's right. The answer is F is the set of all 3x such that x is an element of n. Now let us have another one. Write in set builder notation the following in 5 seconds. That's right. The answer is G is the set of all 3x such that x is an element of n and x is greater than equal to 1 but less than equal to 33. Now, exercise time, do worksheet number 9 in the Google Classroom. Please type your name, student number, and class before you answer. That's it for now. Thank you for watching. Please do subscribe to my channel. See you again next time. Bye!